In this video we're going to look at how to solve simultaneous linear equations by the method of elimination. So this first example, we have two equations with x and y, and if there is a solution to this pair of simultaneous equations, then we will find a value of x and a value of y which makes both of these true. And I'm going to try this by eliminating one of the variables. Now, in order to eliminate one of the variables, I need to either have the same number of one of the variables in each equation, or I need to have opposites in terms of one being positive and one being negative. So in this case I have positive 3y in the first and negative 3y in the second. So I'm going to number these 1 and 2, and then I'm going to add the two together. So I'm going to do equation 1 added to equation 2. And I'm going to do this because the positive 3y and the negative 3y, when they add together, will become 0. So when I add these two equations, I'm going to add the left sides together and I get 7x, and the right side together and I get 21, which gives me a simple linear equation to solve. So I'm going to divide through by 7 to give me x equals 3. And once I've got that value of x, I'm going to sub x equals 3 into, and it doesn't matter which equation here, I'm just going to use equation number 1. So 2 lots of 3, add 3y equals 21. So 6 plus 3y equals 21. So 3y is 15 and y is 5. So x equals 3 and y equals 5. And if we consider this graphically, that means they will intersect at 3, 5. In this second example, we're going to try and approach this with the same idea, but it's not quite as straightforward because I don't have the same number of x's and I don't have the same number of y's. So I'm going to transform these two equations to mean that I do have the same amount of each number. And I've got a couple of options here. I can either make the x's the same or I can make the y's the same. And in this case I'm going to make the y's the same. So I'm going to look for a common factor of 4y and 6y, and I can see that common factor could be 12y. So to acquire that, I need to do 3 lots of equation 1. So I'm going to just multiply everything in equation 1 by 3. And then to get the same outcome for equation 2, I need to multiply that by 2. So that will give me 10x plus 12y equals 26. I'm now going to subtract one equation from the other, and that's because I have positive 12y in both equations, and positive 12y subtract 12y will eliminate the y's. So I'm going to just show equation 1 subtract equation 2. So that will give me negative x equals negative 5, and therefore x equals 5. And then I'm going to substitute x equals 5 into, and I'm just going to put equation 1 again, although I can use any equation I like. So 3 lots of 5 plus 4y equals 7, 15 plus 4y equals 7, 4y equals negative 8, and y equals negative 2. So x equals 5 and y equals negative 2. And again, if I think of this graphically, then that tells me there's an intersection at 5, negative 2.